All right, so welcome to the Virginia Cyber Range Weekly Workshop. This is David Raymond. Make sure I'm not muted here. Not muted, good, okay. So we're gonna continue on our discussion of CTF challenges, and we'll get to that in a few minutes. How about that? If I can make my clicker work. So I've shown this last couple times, we've done this, but if you want to play along, that we have a couple things available. There's a practice CTF that's up that you can jump on and solve some CTF challenges with me. So go to vacker.io/practice-CTF and then just register if you haven't already. If you've already registered, then log in and you can continue with solving challenges. If you registered but forgot your password, then there's a password reset button on the login page and you can get your password reset. If you want to have a Linux environment available to hack on some of these challenges, then most of you probably have access to a Cyber Basics environment. If you don't, you're welcome to go ahead and go to the Virginia Cyber Range login page, and then there's an invitation code provided here, and that invitation code will expire in a week. So if it's past March the 12th of 2019 and you're listening to this and you want access to this Cyber Basics environment, then just jump on your email, send a note to support@virginiacyberrange.org, and we'll get a new invitation code out to you. Okay, overview. Weekly workshops, coverage of cybersecurity material once a week. Tuesdays at 1 p.m. if you want to listen live. Most folks listen to the recording later. So the recordings are all shared at https:/virginiacyberrange.org. Click on the community page and you'll see a button there for weekly workshops. We also have a YouTube channel. So Virginia Cyber Range on YouTube, and all these workshops are out there too. If you have a particular topic you'd like to see, send us an email to contact@virginiacyberrange.org, or send an email directly to me, and we will add your item to the list. And right now we're in the middle of a series covering CTF challenges. So if you're listening to this and it's still like March, April timeframe of 2019, and there's a CTF related topic that you want to delve into, then throw that in the mix and we will get to that. All right, and let's hit a couple of news stories. We'll do this quickly so we can dive into solving some more networking challenges. So Coinhive, Coinhive is shut down. We talked about Coinhive in one of these weekly workshops before Christmas probably, so that would have been late 2018. Coinhive is a website, and this headline calls it a cryptojacking service, and that's really not, the people who created Coinhive, they would argue that that's not what they are. They or what they were. They basically what they allowed was crowdsourced crypto coin mining, and the way they did that was that they provided JavaScript code that you could put in your web browser and in your web page, and so when somebody came to your web page, it would cause their CPU cycles to mine Monero, which is a type of cryptocurrency. It would mine Monero for them. So your computer working on their behalf. Well, the people at Coinhive, their take on all this, and it was a startup company. Their business model, I guess you'd call it, was, of course, they got a cut of any cryptocurrency that was mined, any Monero that was mined, so what they said was that, well, you can put this on your web page, and so you can tell people, I'm not going to serve you ads. Of course, most web pages, most websites make money by through the whole ad system that's run by Google and others. so companies can buy ad space on these different platforms, and you know, and ads are kind of annoying, right? Particularly when they keep popping up and you're trying to shut the ad down, and you know, they cover half the web page and et cetera. So people in general don't like ads on their web pages, but we sort of suffer them because you want to get the content, whatever it is, news or Facebook or whatever. But what Coinhive's business model was that that you could tell your people who visited your website, hey, I'm not going to serve you ads, but in lieu of ads, you can, in lieu of ads, we're going to have your computer do some work for us while you're visiting our webpage, and then when you leave the webpage, that work is going to stop, and it's sort of, you know, trading compute cycles for the ability to go to the webpage instead of ad revenue. But what really happened with Coinhive was that malicious people latched onto this, and instead of putting it on their own legitimate web pages, what they would do is they would hack other people's web pages, and they would put this Coinhive JavaScript software in the web page, but the account for the wallet that the mined cryptocurrency would go into would be the hacker's account, not the owner of the web page's account, right? So it led to this type of attack called cryptojacking that was really popular, has been popular over the last 6 or 8 months, maybe a year. And they also were able to make it work so that even after you left the web page, the JavaScript would keep running, and so even after you're done visiting the web page that had been hacked, there's a JavaScript program that's mining cryptocurrency in the background using compute cycles of your computer, and that money, you know, that mined cryptocurrency would go, of course, to the hacker. And you know, one laptop or one desktop mining cryptocurrency is sort of this tiny drop in the bucket, but when somebody could maliciously cause hundreds or thousands of desktops or laptops to mine cryptocurrency, then that could actually turn into real money. You know, not a huge amount of real money, but it could turn into real money. So it was pretty popular. And you know, what's the negative impact on the person whose system gets cryptojacked? Well, first of all, your compute cycles are going to be devoted to this crypto mining activity. So your so your computer's going to be sluggish, right? You're going to click on a thing and it's not going to work very quickly, or it's, you know, you're going to get the little spinny wheel on the you know, Windows Explorer page or whatever. So so it causes your system to be very sluggish because your system is busy mining cryptocurrency for somebody else. It also causes your computer, of course, to draw more energy because it's because the CPU is running hard where normally it would be not doing very much most of the time. But Coinhive is shutting down. Why is it shutting down? Well, it's not because Coinhive was upset that people were using their site for cryptojacking. Coinhive didn't care. They just got a cut of whoever was, you know, they got a cut from anybody, whether it was a criminal or not, and just turned out that most people who were using their site were criminals. But really, the reason they shut the service down was because it wasn't cost effective anymore, right? So the cryptocurrency market crashed, and you know, we saw this really starting late last year. You know, Bitcoin, you know, the value of Bitcoin was, you know, up in the, you know, $18,000 to $20,000 range. Now it's closer to $4,000 or less. The value of Bitcoin is actually less than what it costs to mine Bitcoin. And so this is kind of could be, you know, unless the Bitcoin market or the cryptocurrency in general, unless the cryptocurrency market improves significantly in the relatively near future, this could be sort of the tip of the spear in terms of companies who are going by the wayside because it's not cost effective to mine cryptocurrency right now. And so everybody who's mined cryptocurrency for the last like 4 months or so has been doing it at a loss. You know, it's cost them more in power, the power draw than it's worth in terms of the cryptocurrency that they're able to mine. But they're betting that, you know, they've already made this initial investment in all this equipment that's designed specifically to mine cryptocurrency. So you can't just turn all your systems off. They have to be doing something productive. And they're betting, you know, these people who are doing this are betting that the value is going to go back up. So even though, you know, the currency isn't worth the spend on it right now, you know, if the value of Bitcoin, for example, goes back up to $20,000 again, then those people are gonna in the end make money. So it's like any other investment. They're betting that the market is going to turn around. So we'll see what happens. So the second news story here, latest WinRAR flaw being exploited in the wild to hack Windows computers. So WinRAR is RAR, archiver. I forget I don't recall exactly what the RAR stands for, but it's a archiving software. So it's like, if you think of like zip, you know, you zip files, you zip things up to compress them so you can send them over the network. You know, the small file size is smaller, so you can send it over the network easier, that kind of thing. So it archives files, and WinRAR is a pretty popular Windows-based tool for archiving, and it uses various different archive formats. You know, so there's not just one. You know, WinZip or the zip protocol isn't the only archiving format. There's a whole bunch of them that date back to the early days of computing, and they're used for different things. You know, sort of the classic example is tar. The tar file is used in Unix systems, you know, back in the 70s, used to condense data to put it on tape archives. So WinRAR has been around for about 20 years, 19 years. And it turns out that there's a code execution bug that has been there since this software came out 19 years ago. And so this just, I mean, I think this is an interesting story because it's this, you know, it just shows that, you know, just about every software has some vulnerabilities, and some of those vulnerabilities are just, you just don't know about them, and until somebody discovers the vulnerability. And, you know, this particular vulnerability has been there for 19 years. That's obviously a long time. But to exploit this vulnerability, somebody can maliciously craft an archive file that can cause arbitrary binary code to be executed on the target system. And that's like jackpot for a hacker. If you can get arbitrary code to get executed on the target system, that's the best you're gonna, you know, that's the best you could hope for. And this particular bug, and all you have to do is craft an archive that somebody uses WinRAR to open. And if you can do that, you can get arbitrary code to run on their system. That means you can get a piece of software that was in the archive that you sent them to run on their system. And so with that, what an attacker would do is they would, you know, have some callback where the software calls back to them, and, you know, there's some botnet software or whatever installed on the system, and you know, again, that's kind of jackpot for malicious hacker people. It's a path traversal bug, so it lets the person install the program in the startup folder where it'll get executed automatically. Identified by some security researchers at a company called Checkpoint. And what WinRAR says, obviously, is all users are advised to install the latest version of WinRAR as soon as possible, because if you don't, then you could be vulnerable to this. So a bug, a very severe vulnerability that's been resident in that software for 19 years. And this is not, I mean, you may not have heard of it, but this is very widely used archiving software. So it's kind of an interesting story about about vulnerabilities and how long they can remain in software. Okay. Oh, yeah. So more news here. So I'll be quicker on this news story. Researchers uncover a ring of GitHub accounts promoting 300 plus backdoored apps. So GitHub is a place where people share software, right? And some of that software is executable programs, but really most of the software is software libraries that other people use to incorporate into their own code. And I teach a cybersecurity class at Virginia Tech, and we've had some discussions recently about the danger of using other people's code. First of all, is very common in software development. You know, in fact, in some cases, developers are told never write your own whatever, like never write your own cryptography software, because there are so many ways to screw it up, and there's lots of stories about companies who write their own crypto and they do it wrong, and they get you know, they have all these glaring vulnerabilities. So people say don't write your own crypto. Use the software libraries that already exist in languages like C and C++ to incorporate into your software. So software developers, you know, they want to reuse code as much as possible. And in sites like GitHub, that's where this code is shared. And so there's a danger now of people either purposely or on accident having vulnerabilities in these software libraries that are shared through sites like GitHub, and then, you know, people are hacked because of code that they didn't even write. This particular story is about a whole bunch of backdoored apps and software libraries that are that all share the same sort of purpose, I guess, the same payload. They're all designed to download a particular malicious software called Supreme NYC BlazeBot. And so this part of the story is interesting, I thought, but what I thought was more interesting was I didn't know what Supreme NYC BlazeBot is. Turns out that it's malware that is used to buy sneakers, and there's this huge market for these high demand sneakers that are almost impossible to buy unless you use these bots. And so this software is this bot that'll buy sneakers, and so this is an example of these Adidas Yeezy Boost sneakers that are being resold on this website for $1,100. Crazy, I know, huh? So these people called sneakerheads, I'm an old guy, so I don't know what all this means, but sneakerheads, I'm sure the young kid, if I talked to my 15-year-old about this, she'd be all over it. They use bots to cop, and I guess that means to purchase their grails. And so a grail is a most coveted sneaker. And so they'll cause this malware to get installed on your computer to buy these sneakers, and I don't know, I guess it gets shipped to them or something. Anyway, that's a couple of more news stories. Okay, so today we're going to talk some more about networking challenges, right? So last week, let me quit this and go to my other slideshow. I'll start my VM here while I'm before it shuts down on me. So okay, we'll come back to that in a minute. So last week we just started talking about networking CTF challenges. So the history of CTF challenges so far that we've talked about in these workshops, we sort of talked about some high-level approaches to all challenges. So how do you think about CTF challenges in general, and what are some of the clues you can use to discover even what you're supposed to do, right? So some of these challenges, it's not even clear. You might be given a file with absolutely no context other than that it's a networking challenge, or it's a crypto challenge, or whatever, or reconnaissance challenge. And if it's a reconnaissance challenge, the file could be just about anything. So we talked about some hints for sort of in general, how do I approach CTF challenges? And then we talked for a couple of weeks about cryptography challenges. And then last week we talked about networking challenges. So we just delved into what networking challenges are all about, and actually we spent a lot of that time talking about Wireshark and how to use it. So today we're going to actually use it to solve some challenges. So with Wireshark, let me go to full screen mode here. Wireshark is one of a handful of different software packages that you use to analyze packet captures. So we did that live real time. We did it in the Virginia Cyber Range so that we could analyze traffic between. This is what we got to last time. So we looked at the TCP and the HTTP traffic between the Kali Linux VM using Wireshark and the vulnerable web server in the Cyber Basics environment. So this is a cool exercise. This one I have up on the screen here. I guess I should make these slides available for folks, but This is a cool exercise for class, right? You put this up on the screen and you have your students work through these. Have them capture the HTTP traffic using Wireshark, and then you ask some questions about it, right? Find the TCP three-way handshake between the web browser and the web server, and then with that you can go back and talk about some of the networking stuff that you maybe have already covered, and then you can talk about what's the IP address of the Kali Linux host, what's the IP address of the web server. Of course, these are my values. Oops, my pen quit working again. It's Microsoft Surface. The greatest tool. So these are the IP addresses in my Cyber Basics environment. Yours are going to be different because these because each of the hosts in the Virginia Cyber Range has its own IP address. But my Kali Linux box had IP address 10.1.112.25, and my web server in my Cyber Basics environment had 10.1.125.25. Web server is using Linux, so we were able to look at the header information in the HTTP packet to decide that the operating system on the web server was Linux, running Apache as the actual web server software, and then we looked at the page source between, both in Wireshark and in Firefox, and we got to see that in Wireshark, which is just looking at packets that are traversing the network, but in Wireshark we can actually drill down and unroll the actual web page and see the HTTP traffic, or the HTML page that was sent from the web server back to the client. So pretty cool stuff. There's lots of neat things you can do with Wireshark and analyzing network traffic. So this week we're actually going to do some of that stuff. So we're going to use Wireshark to solve some CTF challenges. There are other ways to approach these challenges. There are things like TCP dump and ngrep and et cetera, but really you can solve most of the CTF challenges in networking that you'll see. You can solve them with Wireshark. It's very full-featured and powerful. So it's helpful to recall the TCP ports that are used for some of these protocols. These are not always, these protocols are the default protocols for these particular, the default port numbers for these different protocols. But it's the case that when you configure your server, whether it's a web server, an FTP server, a Telnet server, or whatever, you can configure the server to run on a different port if you want to. So why are there default ports in the first place? Well, because your web server, when it connects to, your web browser, when it tries to connect to a web server on the far end of a connection, the browser has to know what port that web server is running on, or it won't be able to find it. And the same is true if you just fire up a Telnet client and you try to connect to a Telnet server. The Telnet client has to know what port the server is on in order to find it, and if it's not running on the standard port, then the client has to know what the specific port is that server is listening on, or the client can't connect to it. So the default ports are there for a reason. So why would you change the default port? Well, there's this, folks may have heard the term security by obscurity, right? So you may have a web server that you only want to be available to, or you only want the people in your company to know about it, for example. So it might be a web server that has information about the company, and maybe it's not super secure data, but it's not data that you want just anybody browsing to anytime. So you might run that web server on an alternate port. One very popular alternate port for HTTP, for example, is 8080. So sometimes when you browse somewhere, you'll see URL, so you'll see something like www.example.com:8080. And so if you run your HTTP server on a different port other than 80, you have to add this colon and then the port number on there. So if you've seen that, that's what the colon and then the number is all about. So HTTP, so common protocols that you're going to see in web challenges, you're going to see lots of HTTP stuff, and this is in the clear web communications, right? It's running usually on TCP port 80, although not always. So actually, actually turns out that some CTF challenge, the folks who set up the challenges, they'll have multiple web servers running on the same host, the same server. And so if you're going to have multiple web server software running on the same server, then you have to supply the port number for the servers, because only one of them can listen on port 80 and the other ones have to listen on other ports. So I guess in the case of CTFs, you may see this thing more often where you have to, where you'll see a URL, url.com : and then a port number. Yeah, so but 80 is the standard port for HTTP. FTP, file transfer protocol, standard port there is 20 or 21. Telnet, standard port is 23. And so these are what I've provided here are the web filters that you use in Wireshark to look for this particular kind of traffic, right? So last week we talked about the filter language for Wireshark. And so here, if you use tcp.port = 80, then that's going to look for traffic in your packet capture that is over port 80, and so that's HTTP traffic. FTP and TFTP, tiny FTP, they run on port 20 and 21. So in FTP, you have port 20 used for the control traffic, and port 21 used for the data traffic. And so if you're going to use a filter to see all that traffic at the same time, then you're going to say, I want to see packets. God, this pen always does that. I want to see packets that are on TCP port = 20 or TCP.port = 21. And in Wireshark, maybe what we have to do is this, not or. You have to do this thing, I think, or maybe the or will work. I don't remember. We'll try it in a minute. For Telnet traffic, generally runs on port 23. For SMTP, so email communication protocols, there's multiple of them. There's SMTP traffic, simple mail transfer protocol. It runs on TCP port 25. That's what mail servers use to communicate with each other, and server to server email traffic goes over port 25, and then you have the protocols that are used for the clients, for the mail clients that run on your system, like Exchange or like Outlook or something. They might use Post Office Protocol, which runs on TCP port 110, or they might use IMAP protocol. I'm not sure what that stands for. It escapes me right now, but that runs on TCP port 143. And sometimes you'll see email traffic on your in your network traffic. And then protocols to ignore things that, so if the traffic is encrypted, and nowadays, of course, more and more network traffic is encrypted. Unless you have a way to break the encryption, then you can basically ignore HTTPS traffic, SSH traffic, SFTP traffic, SMTP traffic, because that traffic is going to be encrypted. And again, unless there's some way to break the encryption, you're not going to be able to unroll those packets. Okay, so let's solve some challenges now. So those are the common protocols. What I'm going to do now is I'm going to go into my Virginia Cyber Range virtual machine. And I'm actually going to full screen this thing. I'm going to click the button again. So I'm logging into my Cyber Basics environment. Student. And I'm going to open the web browser. And I'm going to go to practice CTF, practice CTF. And I'm going to log in. And I'm going to hope that I know my password. Okay, so here I am. Let me, it's a little bit smaller so I can get more of it on the screen. Okay, so here's my CTF. People are killing me. Sorry, just dropped my Slack notifications. Networking. So we'll drill into a couple of networking challenges, and we'll start with some easy ones. And recall that the low point challenges are the easiest challenges to solve. And so I'm going to start with this first networking challenge on our practice CTF. What is the MAC address of the system at, then there's an IP address here, 192.168.9.128. So 192.168.9.128. And there's a packet capture, right? So lots of networking challenges have a packet capture associated with them. So I'm going to open that in Wireshark. And we see network traffic, right? And we're looking for a particular device. So let's say, let's say IP.adder equals 192.168.9.128. And that's going to find all packets to and from that IP address. And so I see here at the very top here, source address 192.168.9.128. And so I'm going to select that packet. That's already selected. So when I select that packet, what I see down here, remember the hierarchy here is I have the physical layer. There's all the physical layer information. Here is the MAC layer, the medium access control layer. And then on top of that, you have the IP layer, Internet Protocol, and then you have the TCP layer up on top of that in this case. And then, so this is part of a TCP through a handshake, so you don't have any application layer data, but it looks like it goes on to do some kind of, what's it doing here? DNS lookup, I guess. So we're going to start with our IP address, right? So we have the source of the traffic. The IP address of the source is 192.168.9.128, and that's what we're looking for in our CTF, right? So if I go back, if I go back to my, oh, come on. If I go back to my CTF challenge, 192.168.9.128, and I'm looking for the MAC address. Okay, so the MAC, so we found the packet with the right source IP address. Okay, now we need to figure out what the MAC address is. And if you recall from your networking stuff that you've covered so far, we know that the MAC address is the layer 2 address in the network protocol stack. So IP address is at layer 3, MAC address is at layer 2, and if I look at my Ethernet frame here that sits right below the IP header, I see that the MAC address is 000C29B4F1C2. So let's see if I can just cut and paste that sucker out of there. No, I can't. I can't do that. All right, so I'm gonna go back to, so 000C29, 000C29, and then the rest of it is B4F1C2. B4F1C2. And I'm going to submit. Bloop. Oh, that's not it. Really? Oh, it's because I put a V in there instead of a B. B4. Ah, okay, that's it, right? So, again, how did we get that? The challenge gave us an IP address and it asked for the MAC address. So we looked for a packet with that IP address. We found the very first packet here, and it's got a source address of 192.168.9.2128. That's the address we're looking for. And the MAC address is the layer 2 address that's associated with that source address. So if I look at the source MAC address, then I see that it's 000C29 B4 F1C2. And I put that in, and that's the correct answer to that challenge. Okay, so let's go on to, okay, this is just the reverse, right? What is the IP address of the system with MAC address 005056FA00B1? And there's a web capture, okay? Now you know how to solve that challenge, so I'm not gonna go through that one. But you could look up that MAC address on Wireshark. Instead of looking up an IP.adder, you could look up the MAC address, and you could find a packet with that MAC address, and then you could find the corresponding IP address. So pretty straightforward. All right, so another networking challenge. It's called Unsafe Protocols-Telnet. Telnet, okay. Learn some things about the wonders of insecure protocols. The answer is what is inside the curly braces. Okay. Unsafe protocols, Telnet. Learn some things about wonders of insecure protocols. The answer is what is inside the curly braces. Okay, so what I've got to find is a flag in this, looks like Telnet traffic. And it's, the flag is inside curly braces, so it should be easy to identify. So, so if I go back to my slides, if I look at common protocols, we said that Telnet is usually the default, the port for Telnet is port 23. Okay, well, let's try in our filter tcp.port equals 23. Oh, and there's no TCP port 23 traffic. Okay, well, there's no TCP port 23 traffic. Let's try something else. So this is obviously Telnet not running on the default port. Is Telnet, let's see if I can use Telnet. I use Telnet in the filter bar, and again, no response. No result, so I guess it's looking for, I guess when I put Telnet in, really what it's looking for is the same thing, traffic on TCP port 23. In some, for some protocols, Wireshark is able to drill into the protocol and display it even if it's not running on the standard port for that protocol. But in this case, looks like with Telnet, it's not able to do that. Okay, so, what do I do now? Well, so this is not a huge packet capture. You know, a few hundred, few dozen, maybe a couple of hundred frames. So you know, sometimes these packet captures you get will be huge, and they'll have a whole bunch of traffic in them, and only a small bit of the traffic is related to the challenge that you're trying to solve. And you know, the idea there is that the person who created the challenge wanted to sort of bury what they were doing in a whole bunch of other network traffic to make it harder to find. You know, it's a little more security by obscurity. In this case, we have a 20-point challenge, right? So the expectation is not super high here. 20-point challenge. So I'm going to assume that that this traffic is going to be pretty hard to find. I mean, what I could do is, you know, if this was some high point challenge where this particular traffic is buried in and amongst a whole bunch of other traffic, then what I could do is I could go look at the Telnet protocol like for example, I could go into Google and I could say Telnet protocol, and I could drill into, well, this isn't telling me much. I guess what would help me more is if I was to say Telnet protocol headers, the Telnet protocol. Okay, so here's what a Telnet header looks like. Telnet overview, and by drilling into the protocol itself and looking at the different commands that it uses, then I could potentially look for very Telnet specific traffic, and I could search for things in this packet capture to find that, and that would take more work than just looking for a particular port, right? And it would also take more work than what I'm going to do right now, because what I'm going to do right now is I'm going to try to take a simpler approach to solving this challenge without having to dig into the Telnet protocol. Again, this is a low point challenge, so I don't expect it to be super difficult. So if I look at the packets here, I see that there's at the very beginning SYN reset. So I'm sending a SYN packet from a host 127.0.0.1, and that packet is getting reset. And then the client is sending another SYN packet, and the server is rejecting it, right? It's giving a RST ACK. So what you would expect in a three-way handshake is SYN, SYN-ACK, ACK. And here I see that there's SYN and then a reset from the server, and basically that means that the server is rejecting the connection request. So the client is trying to connect on port 888 and the server's rejecting it. Try to connect on 888, reject. Try to connect on 888, reject. And then I see, okay, now we're trying to connect on 8888, and here we have a SYN-ACK and an ACK. So this looks like a successful connection from a client to a server. So let's look at one of these. And the way to look into this network traffic is to follow the TCP stream. So I just clicked on one of these packets that looks like it's a successful connection that's being set up. I'm going to right click. I'm going to go to follow and then TCP stream. And it's blank, right? So basically that tells me that there's no application layer traffic in this exchange. What this window will show is the application layer traffic going back and forth between client and server. So this says there's 2 client packets, 3 server packets, and there's no application layer data traded. And so here's that TCP stream. There's a SYN, a SYN-ACK, an ACK, and then a FIN-ACK. So that's the server closing the connection. So it didn't reject the connection. It actually allowed the client to connect. It completed the three-way handshake, but then the server basically immediately turned around and closed the connection using a FIN flag in the TCP header. And the client sort of responds to that, says, okay, I'm resetting. So that wasn't very fruitful, right? This traffic on port 8888 was not fruitful. So I'm going to close that. So I click the X here, and that clears the filter. And now I can look for the next thing that might be interesting. Whoops. Clear the filter, dude. Okay, so now I'm going to go over here. So I'm going to assume that the connection on 8888 maybe is not going to do what I want. So there's several of these attempts to, and they all kind of look the same, right? SYN, SYN-ACK, ACK, FIN-ACK, and then a reset. SYN. Now we have, and those were on 888. Now I have something happening. It looks like on port 4000. So several unsuccessful connections on port 4000. So SYN, reset, ACK, SYN, reset. So this is the client sending a connection request, the server rejecting the connection request. But here now I have SYN, SYN-ACK, ACK, push ACK. Okay, so now I have a connection. Now from my flags, it looks like I do have a connection between client and server on port 4000, and and this is sustained for a while. There's not this, there's not this FIN that's causing the connection to break down. Okay, so let's follow this guy and see what we find. Follow TCP stream. Here we go. This is more interesting, right? It says, hello world, do you know what Telnet is? It is an old school protocol where the flag is, should I tell? I don't know. Let me think about it. Maybe I should stew. My bad. Sorry about the misspelling. Okay, so it says, here is the flag. Sorry for making you wait. And here's the interesting thing about this traffic. When TCP shows you this traffic when you follow the TCP stream, again, this is the application layer traffic, so this is Telnet traffic going back and forth between client and server. The red is the client, the blue is the server. And so all this stuff in red is the client, is coming from the client side of the TCP connection. The stuff in blue is the stuff coming from the server side. So basically this was created, I didn't create this, but you know, one of my students created this, and you know, basically he had the client and the server running as virtual machines on the same computer, and he, you know, got on the client side, made the connection, typed some stuff in, and then he got on the server and typed some stuff in, and so that's why you get the client side of the conversation and the server side. So he says, here's the flag, sorry for making you wait, and then there's this thing, and then it says, oh wait, this is so if you remember the hint, let's go back to the hint. The hint said, the answer is what is inside the curly braces. Okay, if I go to this, it says, here's the flag, but there's nothing inside curly braces, so that makes me say to myself, maybe that's not the flag. Oh wait, that is a non-standard encoding, hope you can figure out, if not, oh well. Okay, so this challenge isn't as clearly straightforward as we were hoping it was going to be. You know, this is not the flag, right? So I can take this, you know, this could be a ruse. Maybe this is the flag. So I'm going to take that, and I'm going to see if I can copy, right click and copy, and I'll go here, and I'll put it in, submit, and that's not the answer, right? Okay, so it says, oh wait, that's a non-standard encoding. Hope you can figure that out. If not, oh well. And here it's this string of uppercase, lowercase, and numbers. And at the end, it has a single equal sign. Okay, well, if you were with us a couple weeks ago while we were looking at crypto challenges, you'll recall that we talked about some various, you know, before even we get into crypto, lots of the very low end cryptography challenges really aren't cryptography, they're just encodings. They're using some, you know, some standard encoding mechanisms, and there are different encodings in computer science for different reasons. This particular one is used to encode binary traffic into ASCII characters, and the reason you would do that is because some protocols, and one of them is Telnet, some protocols don't allow binary traffic to get sent back and forth. The traffic has to be ASCII text. You know, ASCII is an acronym for something, but basically it's text. So it's uppercase, lowercase letters, and numbers, and a few special symbols. And so this thing says this is non-standard encoding. Hope you can figure it out. So really, what it wants me to do is decode this message, and so it has an equal sign at the end. And to me, that screams base64 encoding. So I would remember equal sign at the end is base64 encoding. It could be 1 or 2 equal signs, or it could be 0 equal signs. So some base64 strings have 0 equal signs. The equal signs, so base64, the number of characters has to be divisible by 3. And so if the output is not divisible by 3, then the base64 protocols will, or the base64 encoders will append either 1 or 2 equal signs at the end to pad it out to divisible by 3. And so if you see base64, so sometimes base64 encoded stuff won't have an equal sign at the end. If it does, that's a dead giveaway. And on these low point challenges, you're almost always going to see that equal sign. So I'm going to go to my old standby ASCII to hex.com, ASCII to hex.com. And ASCII to hex, again, we looked at this when we were looking at cryptography challenges. It's used to change ASCII back and forth from various different encodings. One of them is base 64. So I'm going to paste my thing here, and I'm going to click on convert. And it takes me back over to the top of the page, the box where it says text, and here we have the flag. And it says, if you remember the hint, said the flag is what's inside the curly brackets. So I'm going to copy that. I'm going to go back to my challenge. And paste in the right thing this time. And there I've solved my Telnet challenge. Okay. Wasn't super hard. Let's look at another one here. Insecure protocols, HTTP, learn some things about the wonders of insecure protocols. The answer is what is inside the curly braces. So this is another similar challenge, was using HTTP. So I'll leave that as an exercise for the user. Morocco mole, secret squirrel has a flag hidden in his DNS records. Can you find it? So this is a different kind of networking challenge, because you see there's no packet capture here, right? And 25-point challenge, so still not super high points, but this is something that requires you to drill into the TCP or into the DNS protocol a little bit. And if you recall, if I use something like NS lookup or dig, I could say, so this says secretsquirrel.com has a flag hidden in his DNS record. So let's say if I can say NS lookup secretsquirrel.com, and I see that there's an address here, 4555.189.36. Okay, but that didn't. Is that the answer? It's probably not the answer, right? So again, a flag hidden in his DNS records. So how might I solve something like this? I always go to Google if I am not sure what to do, and so one thing I do know about DNS is that it has different types of records that can be stored in it. And if we looked at some of the networking content in the CyberRange courseware area, you would see that there are things, for example, called A records, and that's the most commonly referred to record if you're trying to convert a host name like secretsquirrel.com to an IP address. That's an A record. But there are other kinds of DNS records. So maybe I Google DNS record types to get a sense of where I might hide data in a DNS record. So there's A records, there's quad A records for IPv6, there's aliases, there's C names, canonical names for an alias, there's an MX record that tells you where your mail server is, there's a name server record that tells you where your DNS server is, there's pointer records that point to other records, there's start of authority records, there's all kinds of crazy stuff going on in here. The particular if you were to drill down, spend a little time reading through these different record types, you'll see that there's one of them that lets you store basically arbitrary text in a DNS record, and it's this TXT record. TXT record is a type of source record in the DNS system used to provide the ability to associate arbitrary text with a host or other name. Arbitrary text. Okay, so I can store arbitrary text in this DNS record type. So that to me is you know, saying, hey, that might be somewhere to look. And there are a couple of different tools for doing these lookups. NS lookup is one tool for looking up DNS information. Another one is called dig. And it turns out that dig has a feature So if I was to go over here, for example, and say dig secretsquirrel.com, I get more information. I mean, I get the same IP address out, right? So this is the AA record. And so dig in general gives you more information. And there's actually a way to use dig to get all the different query types. So I can use, so one thing I can do is I can say dig, so there's the type, record type, right, -t type. So I could do this, I could say dig -t txt. So I did this thing where I said dig -t txt secretsquirrel.com, and so here's the flag. It's the txt record, right? It says flag. There's more to DNS than meets the eye. And the point of this CTF challenge, and again the point of most CTF challenges, is to sort of force the students down this path to learning something. And so what they learn on this challenge is they learn, if they solve it, they've learned that there are different kinds of DNS record types, and that the TXT record is a particular type of DNS record that lets you store arbitrary text. And here we hid the flag in it. There is a way to use dig to just spit out all of the record types about a particular domain. And I forget how to do that. Let's Google that. So if you have any CTF challenge that is driving you towards DNS, then if you dig and you just spit out all the record types, you might hit pay dirt really easily. So if I say dig query all record types, command examples to query DNS, list all DNS records on domain using dig. Let's see. There's a machine. That said you can use dig to list the other records by doing. Yeah, that's not quite what I was looking for, I don't think. Oh, dig google.com any. Much easier command. Okay, dig google.com. Okay, so let's say, so dig secretsquirrel.com any. Oops. That didn't give me what I wanted. No manual entry for any. Oh, man, dig any. Dig secretsquirrel.com any. Okay, look at this. So this is a useful command. Dig, and then I put the domain name, and then any. And this gives me all records associated with that particular domain name. And so here I get, I did get my A record, right? I also got my NS record, and I got my flag because it's in the TXT record, and it's all there. And there's my start of authority record. Okay, so that's a good tool. So let's see if I can copy and paste that. Copy. It's kind of a fun challenge. Submit, and there we go. All right, cooking with gas here. I'm going to do one more because I'm already at an hour or beyond. Let's look at FTP. So who logged in? All right. Open with Wireshark. All right, so it's an FTP. It's a network challenge, and the title of it is FTP. So I'm pretty sure it's going to be file transfer protocol traffic, and it says who logged in. So here I'm going to do my TCP.port equals 20 or TCP.port equals 21. TCP port equals 20 or 20. And remember, that's going to give us both the TCP control and network and data traffic. Okay, so here's a synac ACK. And this one's really easy, right? So I got my synac ACK, and I'm gonna go ahead and I'm gonna follow my TCP stream. Follow, bloop. Okay, so So this is exchange between client and server in the FTP protocol. And I did the server, so as soon as the connection was made, as soon as the TCP connection was made, the first application layer traffic that was sent was from the server to the client, and the client sent a 220 message. So this is a common, these numeric responses are very common among, especially these older protocols where they're exchanging text data. So like on a web server, the response from the server that tells the client that yes, I have your page and I'm going to send it to you, that's a 200. On web pages, sometimes you'll see a 404 error. So if you try to go to a particular web page and it isn't there, then you'll get back this 404 error. Again, that's another one of these numerical responses that's very common in these early protocols. And in FTP, same, right? So you have this 220. Basically, that means I'm answering your connection request, and now you got, I'm ready for you to try to log in. Okay, so now the client would type in their username, anonymous in this case, and then the server comes back with please specify the password. And then, so what will happen on the client side is you'll get a prompt for you to type in the password. You type in the password is sent, and if those are valid, then you get this login successful response. So again, the intent of the CTF challenges is to teach students things about these protocols. In this case, we're teaching students, about, first of all, here's the FTP protocol, right? You can see it all right here. Request, here's the login. Here's the, information being exchanged between the client and the server so that they can, successfully send commands back and forth. And then here's some commands being sent from the client to the server. And if we were to drill in on the other component of the FTP traffic, the data component, then you would be able to see the actual files being sent back and forth between the client and server. I'm not going to do that today. Maybe we'll do that next time. But the question in the challenge is who logged in, and the answer is anonymous. So I'm going to copy that. The other interesting thing to notice when you look at the FTP protocol, look at this exchange, is that this is all in the clear, right? So you're seeing both the username and the password being shared in the clear over the FTP connection. Certainly not a good practice, but again, this is an old protocol that predates current concerns about network security. Now the FTP protocol is used less because of this very thing. Now we use protocols like SFTP, secure FTP, or SCP, which is secure copy, which uses the SSH protocol to send data back and forth between clients and servers. Let me go back to my, let's see, I'm going to paste in the answer. Yeah, I'm going to submit. Okay, correct. Right. So we've done a couple, we've skipped a couple. The ones we skipped, you should be able to do yourself. There's a couple of more. Maybe we'll drill into those next time. Anyway, I'm going to stop there for today. So thanks for this of how to update, and we'll see you all next time.